So hello and good morning. My name is Andreas. I'm a professor for IT security at the University of Applied Sciences in Offenburg, which is pretty close to the French border near Strasbourg. And I'm going to speak today about creation detection of German voice deepfakes. This is work done together with some of my final year master students, Vanessa, Pascal, Nicolas, Felix, who more or less left university by now, and Dominic, who still continues to work with me on machine learning and IT security related topics. So without any doubt, synthesizing voice with the help of machine learning has simply made rapid progress over the last years. We have seen a lot of benign application scenarios. So for example, in healthcare, in the automotive industry, in home entertainment. But simply, there's also a relatively high risk of using voice-based deepfakes to commit fraud. We have seen, and there are reports about, for example, so-called CEO phishing attacks, where really the synthesized voice of a CEO was used to perform a social engineering attack. What is just much more worrying is that from a longer term societal perspective, we could argue that we are progressing towards a disbelief by default culture, where people simply do not trust media anymore. And why would that be the case? Well, simply because there are just so many deep fakes around. Yeah, we've seen video, picture-based deep fakes, and as we report in this paper here, voice-based deep fakes. And that was actually our initial question. And our initial question was just how low can we go? So we wanted to understand how easy it would be to actually create a voice deepfake. Easy as in needed data, hardware, skill set. And we actually really looked at this in the context of the pandemic situation, where we were forced to actually provide online teaching. So using tools like, for example, Teams, Zoom, Big Blue Button, Jitsi, it doesn't actually matter which tool you use. And then we try to address the question, if we would be able to succeed to fake a voice in such an online teaching scenario, how convincing would just such a minimal effort fake be? So we try to measure that in terms of user study. So that's actually what we're going to do, or what we did in the paper. We first of all discussed how to set up a machine learning pipeline for creating fake synthesized voice, how to actually train such a model. So what you need, what kind of data, and maybe some very specific things with respect to the German language. Then we set up a user study with over 100 people to just try and evaluate how convincing such a deepfake, voice-based deepfake would be. And in essence, it's pretty convincing. So definitely much better than a fair coin toss. We looked at possible also machine learning based detection methods, and we provide some kind of longer term or discussion of longer term societal impacts, specifically this disbelief by default culture, which I mentioned earlier on. So we use actually Tacotron 2 as our baseline architecture. And it's pretty complex, but there are basically two things we sort of need to understand. If we want to use Tacotron for machine learning purposes, we actually need to train two models. So the first model, which is more or less this part here, if you see my mouse moving, this is just for taking some input text, and from that input text, so basically the text which would trigger the voice generation, and that model would then take the input text and create a so-called MEL spectrogram. And this MEL spectrogram would be picked up by the second trained model, which actually, in essence, is a vocoder. And that vocoder will actually generate voice out of the text. So it's basically a text-to-speech approach. And that works on basis of these two models. And those are the two models we need training data for. We actually published an earlier report on arXiv, where we actually detail a lot of the observed pitfalls. So if you're really interested in reproducing our work or similar work, recommendation is to read that archive report, because there's just a lot of required engineering to succeed in doing this. So training. Well, synthesized voice can only be as good as the quality of the audio it was trained on. Sure, yeah. And our initial idea was, as I said, how low can we go? And we actually used even less than 3 hours of recorded voice from a university professor. In fact, it is my voice. We used about 1.5 hours from real synchronous, as in more or less now, online lectures. And the device that was used for recording my voice was exactly the device I'm using now. It's a small sort of Jabra audio spider. And then we used a material from asynchronous online lecture. So basically where I prepared a video and then put that onto our Moodle learning platform. And that was done with a slightly better microphone, a Rode NT1A, but still, I mean, slightly better, as in that's 150 euros microphone and a 250 euros converter for it. We then used analyse. That's a tool to synchronize transcript with audio, because that's basically what you need. You need the audio as well as the German transcript, yeah, so the supporting text. And that was actually the hardest part for the team, to actually really transcribe me giving online lectures. So the result out of this is about 1,800 audio files, each somewhere in the range of 2 to 20 seconds, plus all the metadata, yeah? So all the transcriptions. And that's basically what we throw at the Tacotron 2 architecture. And there are some improvements. You can get that from the paper. And we used standard train test split approach, so where we divide the training data into a training test and a training set and a validation set. And obviously the sentences we later generated, they are sentences which the model had never seen during the training approach. Yeah? So completely new sentences. We did that for the German language. So it seems not many people have done that for German language before. And the good thing about German language is it's more or less pronounced as it is written, unlike French, or unlike, for example, English. So there are no heteronyms. Yeah? Downside is, because I'm a computer scientist, there were lots of anglicisms in the lectures, and well, sometimes we had to manually identify them and just take them out because they would just pollute our training, or sometimes we just left them in. The whole training as such was done on, well, it is high-end hardware. It's an RTX 3090 from NVIDIA, but high-end basically means it costs about 2,000 to 2,500 euros. So it's actually something probably quite a few people have as part of their gaming setup for doing gaming at home. And the whole training took, it depends a little bit. Actually here, the more you can train, the better. So roughly it took 3 to 5 days in training, which basically means more or less any semi-skilled person. So basically anybody who got a bachelor degree from our faculty, so we actually teach IT security, they would actually be able to do that with hardware ranging somewhere under 5,000 euros. So it's definitely within the reach of an amateur. So what did we do? Well, we tested our trained professor, so me. So the model on 102 participants. So actually we were quite lucky. 102 is not bad for a survey. And we split them in 4 groups. So 19 of them knew me personally 19 of them didn't know me at all due to COVID, which is really unfortunate, but I guess it's the same in your setup. So students you really have never seen before in person. 14 of them knew me from previous lectures, so before COVID. 17 of my faculty colleagues, so definitely they knew me, and just a lots of others, family, colleagues, people I work on or together with in the context of research projects. And yes, sure, the survey we did, it could have been more precise, that's clear. But on average, the results are not bad. We got 4 different cohorts, and we have gotten an average of a correct deepfake identification within 37% of the time, which basically is just much worse than a fair coin toss. So simply, it leads us to the conclusion that not only technically creating deepfakes, voice-based deepfakes, is within reach with relatively little material, so less than 3 hours, taken just from online material, and with hardware for less than 5,000 euros. And that's, in our opinion, it is pretty bad. So let's hear some examples. So let's take a real example here.
Bitte trage bei allen Studenten die Prüfung als nicht bestanden ein.
So that basically means just enter a pass for all students for all the exams. So this one here is a fake.
Bitte schicken Sie mir sämtliche Prüfungen zur Hauptstraße 7 in Offenburg.
So please send all exam results to a certain address close to university. And this one here, I leave it up to you to decide.
Ein weiteres Beispiel für den Einsatz künstlicher Intelligenz ist die digitale Assistentin Alexa.
Basically meaning Alexa as a digital assistant is just another example of artificial intelligence.
Bitte schicken Sie mir sämtliche Prüfungen.
Bitte trage bei allen Studenten die Prüfung als nicht bestanden
Assistentin Alexa.
Sorry about that. Detecting voice deepfakes. So we can actually use something called bispectral analysis. It's a detection technique which has been reported some years ago. And in our case, it actually worked relatively well. So it was really good for detecting the reals. So that 100% detection of the real voice samples, in comparison to only 80% detecting the fakes, which well, it's not that good, but nevertheless, it creates some relatively good partition of the set. We did that in the context of 21 samples. That was the samples we had with respect to my voice. So I just highlighted that here. In case you wonder what the other marks are here, we actually had some other data set with over 200 samples from some German politician. And here you can actually see that this bispectral analysis works relatively well as a detection technique. So in summary, well, number 3 was a fake. I personally think relatively convincing fake, and in essence, really what our assumption, well, actually it was not our assumption. We were actually quite surprised. So our summary would be creating some kind of fake voice is really fully within reach for a skilled amateur. So fully within reach means bachelor degree in in computer science and equipment of less than 5,000 euros and access to about 3 hours of audio material. That's all you need. Detection is possible, but hey, given advances in adversarial learning, so I'm not too optimistic that this will hold on for long. And what will happen? Well, long-term societal disbelief. This is really what we think is the worst that could happen. And because we wanted to actually counter that, we positioned our work several weeks before the German general election a couple of months ago to just raise public awareness that something could really go wrong here. We had been covered by media, so there was actually quite a lot of interest in that. I think 5 or 6 newspaper articles in the more or less local region, as well as relatively good local radio coverage and TV coverage. And local basically means for the entire state of Baden-Württemberg and actually beyond. the references as actually listed in the paper. And with that, well, yeah, it's a shame I can't be there, but actually I'm not supposed to travel these days. Though Paris would have been actually relatively close for me in this context. So hopefully there will be questions, and with that I wish you a good rest of the conference. Bye bye.